Inversion has launched the ARC, the first space delivery vehicle capable of transporting critical cargo to any point on Earth in under an hour, while also serving as a hypersonic testing platform. The Unitree G1 humanoid robot now withstands kicks and pushes with its new anti-gravity mode, using sensors and motors to balance and get back up quickly. Clone Robotics has created androids with hydraulic muscles that mimic human movements, allowing them to cut food and perform complex tasks naturally. These and other technology news await you, and that's exactly what we're going to explore in today's video, right after the intro. Hey everyone, I'm Jefferson, and you're watching More Technology. If you're a tech enthusiast and like to stay up to date, make sure to hit the like button, subscribe to the channel, share this video, and leave a comment below to support the community. So, without further ado, let's get into the video. A spacecraft capable of delivering critical cargo anywhere on Earth in under an hour is now a reality. Inversion, a defense and aerospace company, unveiled the ARC, a spacecraft that combines speed, precision, and full reusability, completely transforming global logistics and hypersonic research. The ARC measures about 2.4 meters tall and 1.2 meters wide, can carry up to 500 pounds of cargo, from medical kits to drones, and does not require a runway to land, using parachutes instead. It can remain in orbit for up to 5 years, ready to descend whenever needed, and can maneuver during re-entry thanks to its lifting body design, covering up to 1,000 kilometers of horizontal range. Beyond deliveries, the ARC also serves as a hypersonic testing platform, reaching speeds above Mach 20 and withstanding extreme conditions and high G-forces, providing a faster, cheaper, and more repeatable method for military research. Its development builds on the success of Ray, a smaller demonstrator spacecraft launched in January that validated propulsion, power, and avionics systems. With drop tests, aerodynamic modeling, and a partnership with NASA for thermal protection, Inversion plans to launch the first ARC mission as early as 2026. With this technology, transporting critical cargo and testing hypersonic systems has never been faster or more precise. And if we could position vehicles like the ARC in orbit for any global emergency or mission, how would that change the concept of logistics and rapid response on the planet? A four-legged robot that plays badminton like a 7-year-old child already exists. Researchers at ETH Zurich created Animal, a quadruped capable of tracking the shuttlecock, predicting its trajectory, and hitting it with absolute precision, demonstrating how robotics has advanced beyond industrial tasks. The secret lies in Animal's control system. 2 cameras monitor the shuttlecock and feed an algorithm that calculates the exact timing of each strike. Equipped with a multi-axis arm holding the racket, the robot uses reinforcement learning, simulating thousands of virtual matches to perfect its movements before stepping onto a real court. Balance is crucial. As it runs and positions itself to hit, Animal maintains impressive stability, even during sudden lateral movements. Originally designed for industrial inspection and rescue in uneven terrain, it now applies the same principles of agility and coordination in sports, proving its versatility and potential for future applications in dynamic environments. With this technology, robots can not only assist with complex tasks, but also compete and train in sports with human-like precision. How might other machines use this same intelligence to transform everyday activities? Unitree has shown just how far humanoid robotics can go. The G1, a 35 kilograms robot, not only withstands repeated kicks and pushes, but also gets back up on its own using a system called anti-gravity mode. Each impact is calculated in real time, as if it predicts the force and knows exactly how to respond. The secret lies in the combination of advanced sensors and motors in each joint. Depth cameras and 3D LiDAR scan the environment, providing precise data on the robot's position and the direction of the applied force. Even before touching the ground, the G1 adjusts its center of gravity, leans in the correction, or takes a lateral step, absorbing the impact and standing up within seconds. During testing, it received frontal and lateral kicks, double pushes, and even impacts while running. Each time, the movement was natural, fluid, and controlled, showing that the robot isn't just reacting. It predicts and executes the optimal recovery strategy. This capability is crucial in industrial or research environments where falls or interruptions can cost time and money. Beyond impressing, the G1 was designed to be functional. Priced around $16,000, it is more accessible than many advanced humanoids and can work in factories, labs, and other settings that require resilience and adaptability without constant human intervention. This anti-gravity mode shows that robots can remain productive even in unexpected situations without stopping after a shock. How far could other machines go in learning to recover on their own like the G1? Exoskeletons used to be heavy, expensive, and inaccessible. But researchers have created Kinethreads, a full-body suit that weighs less than 5 kilograms, costs under $500, and delivers realistic physical sensations in virtual reality. It promises to change the way we feel and interact with VR, without relying on bulky devices or six-figure prices. The secret of Kinethreads lies in the threads and motors distributed across the body. Nylon threads run through channels in the fabric, connected to small motors that act like artificial tendons. When activated, they tension and pull the muscles, guiding movement. A Raspberry Pi controls the entire system via Python scripts, enabling precise coordination between motion and tactile feedback. The suit covers the chest, arms, and legs, using elastic neoprene for comfort and rigid plastic guides to keep the threads in place. On the arms, 4 motors control shoulder flexion, elbow movement, and rotation, while wider straps on the legs stabilize the hips and knees. Additional motors provide vibration, allowing the user to feel resistance from virtual objects or impacts from explosions in the game. Despite its compact size, the system delivers up to 120 newtons of force and vibration up to 200 hertz, simulating everything from the weight of a light object to sharp impacts. All of this is packed into a modular suit, easy to put on in under 30 seconds, making high-quality haptics accessible for VR and rehabilitation, something previously limited to expensive, bulky equipment. Kinethreads shows that the sensation of touching, pushing, or feeling weight in virtual reality doesn't need to be elite technology. Imagine how this could revolutionize gaming, training, and physical rehabilitation. How far could suits like this go to make VR fully immersive? A Polish startup is redefining what humanoid robots can do. Clone Robotics has created androids that don't rely solely on rigid motors. They use water-powered artificial muscles capable of replicating human movements with incredible naturalness. The result is a robot that seems to breathe, stretch, and act like a real person. The team's initial focus was the hand, the organ responsible for most human tasks and with the greatest freedom of movement. In 18 months, they developed a robotic hand with artificial ligaments and monolithic muscles, allowing the entire body to be built later more quickly and efficiently. The secret lies in the hydraulic muscles, inspired by the McKibben design. Rubber tubes wrapped in inextensible textile sleeves contract when filled with water, pulling artificial bones and producing extremely natural movements. A compact system, called the hydraulic heart, pumps water throughout the robot's body, which can be refilled as if it were drinking. The Protoclone V1, a prototype launched in February, has over 200 degrees of freedom, 1,000 muscle fibers, and 500 sensors that measure force, torque, and joint positions. By December, the company launched the Clone Alpha, its first full-scale humanoid robot, and the next step is the even more advanced NeoClone. Additionally, all robots use NVIDIA Jetson chips to control motion planning and sensors that help reproduce precise movements, paving the way for future, sensitive skins that will allow them to touch and interact with delicate objects perfectly. Clone Robotics is creating androids that can literally perform human tasks almost indistinguishably from a real person. With hydraulic muscles, integrated sensors, and artificial intelligence, they are approaching the impossible. Could we one day see robots with these capabilities working alongside us, performing everyday tasks with complete naturalness? Researchers in Portugal have taken an impressive step. They managed to decode the thoughts of mice just by observing their facial movements, all without touching the animals' brains. This discovery not only opens doors to studying brain function non-invasively, but also raises questions about how private our own minds can remain. The experiment began with a simple challenge. Mice had to figure out which of two water spouts contained a sugary drink. The catch was that the rewards switched places, forcing the animals to constantly adjust their strategies. At the same time, the researchers recorded both the mice's facial movements and brain activity. Using machine learning, they found that the subtle signals on the animals' faces were as revealing as directly analyzing dozens of neurons. In other words, the mice were showing what they were thinking through their faces. Even more surprising, similar facial patterns indicated the same strategies across different mice. This suggests that certain mental processes may have consistent physical expressions, almost like human emotions. The scientists highlight that this technique has enormous potential for research on brain health and disease without the need for invasive methods. But they also warn of ethical concerns. If simple videos can reveal thoughts, mental privacy could become a major challenge in the future. The possibility of mind reading through facial movements is still confined to the lab, but the impact of this discovery is huge. Could similar technologies one day monitor our thoughts as directly? So, did you enjoy the content? Then make sure to subscribe to the channel. This helps more technology grow and reach more tech enthusiasts. On your screen, there are two recommended videos, one from the main channel and another from our Shorts channel, featuring straight-to-the-point tech news. Pick one and keep following the latest from more technology. Thanks for watching, and see you in the next video.